we're gonna get started. So, who could raise their hand and tell me what is the slope in this problem? Go for it. $5. How do you know that? That word per, each, every, right? That indicates something's happening over and over again. So I know that's my slope. So 5 is your slope. Because if she's working for 2 weeks, she would earn $10 and so on. What's your y-intercept then? 20. So remember, y-intercept is your initial amount, your beginning amount. So since she initially had $20, that's what she starts with. It's not adding each time by 20. It's just starting at 20. And so what's the equation? Y equals what? Perfect. 5x plus 1. So make sure your slope is your m. It's what's next to x plus 20. And then is this function increasing or decreasing? Why? Good, because you're adding 5. So it's increasing because you're adding 5. And also, like, she's getting more and more money, right? So because you're adding 5 each week, and your slope is positive. So in this lesson today, we're going to be comparing linear and exponential. You guys haven't learned exponential yet. We kind of changed the order since you don't have to take a midterm or anything. So we are going to be going into exponential, and then the last thing we'll do is quadratic and the last data unit. So we do need to move pretty quickly. Like at this point, midterms are coming up for the other classes, which means our first semester should almost be done. So we are a little bit behind. So each period is going to be a different lesson. Before we kind of worked, we used that period to sometimes just like catch up, but this time we have to like do one per period. Cool. You can tell me what the slope of the table is. Anyone get it?
3.
How do you get that? Cool. So you can see, okay, the change in y is 3. So I know it's 3. Divided by the change in x, which is 1, which is 3. Beautiful. What's the y-intercept? 8. Remember OY? Can I never remember the y-intercept? The O will be for when x is 0, and x is 0, y is 8. How do we write that in slope-intercept form? Y equals what? 3x plus 8. And would that function be increasing or decreasing? Increasing, right? Because we're adding 3 each time. So because we're adding 3, it would be increasing. It's also going to be a positive slope. Cool. So circle how you feel about that. That is just like a kind of a refresher on linear. So today we're just going to be looking at word problems and tables just like this, and kind of differentiating between linear and exponential. So what you're going to start with first, there's a little like Mario activity on your desk. And so we're going to be starting with that. It looks like this. And so what it says, you're going to, I'm going to have this half of the room right here. You guys are going to be representing Mario. This half of the room is going to be representing Luigi. So it's saying I'll give Mario 1 gold coin when he starts his job, and every day after that, I'll pay him 3 times as much as the day before. So if you're on Mario's side, you're figuring out how much does Mario have each day. If you're Luigi, I'm going to start you off with 5 gold coins, and I'll pay you 20 more coins than the day before. So I only want you doing, if you're on this side Mario, if you're on this side Luigi, you're figuring out, okay, if I'm Luigi, how much does it say he's starting with? 5. If you're Mario, how much is he starting with? 1. And so we know this side saying 3 times as much. So what's 3 times as much as 1? 3. This one's saying 20 more. What's 20 more than 5? 25. So, and then you're filling out the entire table. So you're going to figure out the entire table and then try to Mario's, what was his day 2? How much gold coins did he earn? Right here. 9. What about day 3? 27. What about right here? 243. What's the next step? Is half the room? You're on that side. Even though you're doing it, I'm happy you're doing it. I want to make sure they're doing it. What is it? Mm-hmm. And the last day. Mm-hmm. And so when you added all this up, what did you guys end up getting? 3,000, what was it? So when you add them all up, you end up getting 3,280. So total Mario has 3,280 coins. Even though he started with 1, he has a ton of coins. What about Luigi's side? What would this be right here? Now you guys can say it. 45? What about right here? 65 here? Here? Uh-huh. And how many coins total? 600. So even though he started with more coins and he's adding 20 each day, who ended up with more coins, Mario or Luigi? Who ended up with more? Mario. So I would rather work for Mario because he would end up with more gold coins. So which one? Mario is multiplying by 3. Would that be linear? Is that what we did in our ticket inventory? Or would it be exponential? Exponential. And it's exponential. That's what our unit is. It's because it's multiplying over and over. See this x in the middle of exponential? I just am reminded, oh yeah, that means to multiply over and over. So exponential means to multiply over and over again. And exponential will always be larger than linear functions. What about, so that means Luigi's, if he's adding 20 each time, what is his? Linear. So linear because it's adding 20 over and over. So do you guys see the difference between linear and exponential? Linear is just adding over and over again. Exponential is multiplying over and over again. And so Mario's deal, I'm going to show you what it would look like. It will look like this, y equals 3 to the x. And we'll learn how to write them eventually, but that's what his deal is going to look like. There's going to be an x in the exponent. I just remember exponential, x in the exponent. Luigi's deal, who can write that as an equation? How would I write that? Go for it. Beautiful. 20x plus 5. It's increasing by 20 each time, and it starts with 5. Perfect. Cool. Does everyone have that down? So now all you're doing is you're looking at word problems and tables and trying to figure out, is it exponential or linear? And so really all you have to do, you can try to find the pattern. If you can't figure it out, what you do, what's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing. So if let's start and see if this is linear. So what's the opposite of adding, you said? Subtracting. So I would subtract the last one minus this one and keep going. If it was the same number, then I would know it's linear. If I divided and it's the same number, I would know it's exponential. Mostly you can look at it and figure it out though. Because I can go, okay, 1, 3, 9, 27, what is it multiply, or is it multiplying or adding over and over? Multiplying. So I know since it's multiplying, it's exponential. What is it multiplying by? 3. And that 3 is called the growth, it's called a factor. So we don't call it a slope anymore in exponential. In exponential, we call it a factor. What about this one right here? Even from here, 1, 3, 5. Is it adding or is it multiplying? Adding. So what would it be? Linear. And it would have a slope of 2. Because when it's linear, it's adding, that's your slope. When it's exponential, it's multiplying, that's called your growth or decay factor. Does that make sense? So I want you to go through and figure out, okay, is it exponential or linear? So first just write exponential or is it linear? And so you could see, okay, 2 to 8, I would have to add 6, right? What's 8 plus 6? 14. Is that 32? Nope, so I know it couldn't be linear. Then I go, okay, 2 times what equals 8? 4. What's 8 times 4? Is that what I got right there? So that will help you out also. So what I want you to do is I want you to just go through it. You don't even need to write the factor or the slope. Just identify if it's linear or exponential. So do that first. Good deal. All right, let's go over it. Stephen, what's the first one right here? Exponential or linear? Beautiful. We know it's multiplying. Yeah, so what's this next one right here? Linear. Keandra, what's this one right here? Perfect. Kamari, what's this one? Linear. Victor, did you get this one yet? What is it? Exponential. Beautiful. Michael, what's this one? This one, right? Brandon, what's this one? Beautiful. And Kristen, you get this one? Perfect. So now what I want you to do is you're just writing if it's linear, you know it's slope. So for every linear, write slope equals. So if it's linear, you know it's sloped. For every linear, you're going to write slope equals. For every exponential, you're going to write factor equals. Now, I want you to see how to get the factor if it looks like it's dividing. Do you guys see how this looks like it's dividing 300 to 150? See how it's getting smaller? To get your factor when it's dividing, you have to turn it into a fraction. So you always just do the last one divided by this one right here. So put that in your calculator. What's 18.75 divided by 37.5? 0.5 or 1/2. Because you can see this is dividing by 2. You just flip it to try to get it as like a fraction. So multiplying by 1/2 and dividing by 2 are the same thing. So you're going through and just writing what the factor is or what the slope is. So I would start with going through all the exponentials and writing factor next to it. And all the linear ones and writing slope next to it. Just so you get used to it. And I'll give you a few minutes and I am going to cold call. If you want to figure out what the linear slope is, you can figure out the pattern, but you do the same thing as exponential, and you do this one minus that one. So 8 minus 11. And that will give you your slope. For exponential, you just do the bottom one divided by the one above. If you can't recognize it. No, that's right. It's only if it were like getting smaller. So like if it started with this and worked this way. Yeah, so that's right. So if it's getting larger, it's not going to be a fraction. Unless the fraction is larger. So now you're just writing slope next to all the different things. Like the word slope and the word factor. Figuring out what the slope was. gonna tell me this top one right here for a brain bug. What's the slope or the factor for this first one? Yep, so your factor is 2. Beautiful. Who could tell me the one below it for a brain bug? Mari, go for it.
-1/2.
Negative. It is negative, but it's not 1/2. Or it is 1/2. Sorry, 0.5. Let's do this. Perfect. Who could give me the next one down here, right here? What's the factor? Someone besides them. If you raise your hand, you'll get a brain bug. If not, if I have to call on you, then you'll get a brain bug. Carlos. Good. Carlos said this is 4 because it's multiplying by 4. Beautiful. You can give me another one. Any of them. You can pick whichever one you want. We're also going to start cold calling. Or do you guys want to be able to earn brain bucks? Pick one. Sure. This one? It's dividing by 3, right? So what's it, when I flip the fraction, what's the fraction? Like 3/1. When I flip it, what is it? 1/3. So you see how it's dividing by 3? Because we need to figure out what it's multiplying by, so it's 1/3. Who can give me another one for brain buck? Remember, 2 is candy. Keandra, go for it. This one? What's the slope? Beautiful, because it's subtracting by 3, so it's -3. Perfect. Who can give me another one? Go for it, come on.
Table 1, there, 5.
Beautiful. It's multiplying by 5. So it's not because it's multiplying by 5, not dividing. It's just going to be 5. And who can give me the last one? What is it? Yes, it is 8. The last one, my slope is 8. Beautiful. So, does everyone understand how we got each of those? Yeah, no, maybe? Cool. Okay, last thing we're doing is looking at word problems. And I don't need you to like solve them or anything like that. I just need you to identify if it's linear or exponential. And so I know word problems exponential, usually if it's multiplying by a percent or a fraction. Or those words like half, double, triple, like there was in Mario example, that usually indicates that it's going to be exponential. So let's look at this first one. It's increasing by 18%. We see that it's increasing by a percentage, and we're going to learn how to write them in a couple classes. But if we're increasing by a percentage, would it be linear or exponential? Exponential. So if it has a percentage, it's usually exponential. Miss Hunter takes off 10 points for each day the assignments turned in late. The assignments are worth 100 points each. Would that be linear or exponential?
Linear.
Linear, right? Because you're subtracting each time. And so because you're subtracting, it'd be linear. How would I write that equation? Y equals, what's the slope?
2x plus 100.
But it's
minus 100.
Well,
Negative.
opposite. -10 because it's subtracting 10 plus the 100 original points on the test. Your salary starts at $23,000 and goes up by 5%. Oh, it's good. Exponential because it's that percentage. You buy a used truck for $4,000 and it depreciates by 12%. What would that be? Good. A painter is to charge $90 for paint and $35 per hour to paint your kitchen.
Linear.
Linear. Because each hour that he's there, how much is he charging? Or who can write this as an equation for a breakup? Mari, go for it.
Which one? The paint one? 35. No, y equals 35x plus 90.
Beautiful. Because it's $35 per hour plus the original money he needs for the paint. Beautiful. What about the next one? If it says a percent right there, it's increasing by 14%. Good. Exponential. And last one, it's increasing by 2.5% each year. So usually if it's a percentage like that, or there's words like double, triple, half, like, or it's even written like this, or multiplying by any fraction, we know that it's exponential. So you can just write that at the bottom. So we know something's doubling, tripling, half, or it's multiplying by a fraction, or multiplying by a percent. We know it's linear if it's adding or subtracting over and over again. Does that make sense? Okay, so what you guys are doing, we're going to give you around like 15 minutes to just practice on the next 2 pages. So what that is you're just identifying if it's linear or exponential. And if it's linear, you're writing the equation. So like A, is that linear or exponential? Linear. And so I would circle linear. And then I know what's my slope? 3, so it'd be 3x. And what's my y-intercept?
2.
Beautiful. 2. Good morning. So you're only doing that for linear. If it's exponential, just circle exponential. And maybe write the factor, what it's multiplying by. The back of that page is word problem, so you're just identifying if it's linear or exponential. And your ticket out the door looks like this. So it's the bottom of your ticket in the door. All you're doing is writing linear or exponential. That's it for all of these. And then for this, you're circling. So you're looking at the table and you're writing it. Is it linear or exponential? You're just circling. Is it increasing or decreasing? Looking at your y values. And if it's linear, does it have a slope or a factor, and vice versa? So if it's a factor, you know it's exponential. If it's slope, you know it's linear. So you're circling one and whatever your slope is. That's all you're doing for both of these, or for your factors. Does that make sense? So these are 2 to get out the doors. The answer key is up here. I did write in the answer key the exponential equation. You do not need the exponential equation. I just wrote it on here. So you're checking your own work, stamping, and then the last 5 minutes will be take it out the door. Sound good? Third period.